Okay, we said that we will try to explain some system functions, system calls or functions, like we have today fork and open, read, close, change dir, getline, and access. So basically, I'm just taking like this copy and go to manual page and like try to explain everything there, or the most important things we need there to use this function. Okay. So we start with access. The screen is okay, or you need to make it bigger. Okay. And like I was in a team, and when I'm trying to explain, they said I'm talking so fast. So because of that, I'm writing while talking to be like slow. So I'm using here the note. Okay. So the first thing we have our access system call or access function, and basically what it do or what it does, it is check for user permission for the file. So like if we have a file and we just want to know uh, are just we have the access for read or write, or read and write, or which access we have on this file, we can use access to like know if we have the access on read or write, or read and write both of them, or what's the access we have or permission we have on this file. So we just will take everything here, copy like this, and we'll break it down. Okay, of course, like to use this function, we have to include this library. And let's take its syntax down. Any function, if you want to use any function, you can imagine it like you are going to someone to help you in something, and you say to him or to her, I want your help. So every function has its condition. Someone will say anything? Okay. Every function like has its condition or has its requirements to be able to or to allow you to use it. Okay, so these conditions or requirements called here parameters. Like we have here two parameters, it's a path name and mood. But the first, let's take this like okay, what is the meaning of int access? Like access is like a variable, or like you can like imagine it like a store. You open this store to like save the return value from the function. So our access here, or the first variable we are using here, it's like a store to save the return value or the result returned from our function, and it has type int. And we will say like why it has type int at the end. So basically what we need at the first, we need a variable. Okay, so here we can say it is a variable to store the result back from the function. Okay, and it's from type int, and that's mean like our function return integer value. So our function will return integer value. So this is called like function parameters. Okay, so our parameters like the function requirement or function conditions to use it. So as the first thing, our function needs something called path name. We said that our function like check the permission on the file. So the path name, it is like the name of the file it will check. Okay, so the path name, it is a variable, or we can say a pointer variable. Hold the file name to check, or the file to check. And our mode here, it's like what do you want to check? Do you want to check the permission of writing or of reading, or any or writing and reading, both of them? So the mode it's what do you want, or what do you want, sorry, to check from the file, or which permission you want to check. Okay, so if we come here like our access, check whether the calling process can access the file which we provided by the path name or not. And our modes here, like we have read and write. Okay, so we have list of modes. The first thing is ROK, and that's like read only, and or write only, and we have execute only here too. Okay, and what else? If here it's like check for the existence of the file itself. So if the file it exists or not. So it's a check. This is mode check for reading. For reading, okay, for reading the file, and write for writing, and the X for executing, and here for existence. Okay. Okay, we can here to look at the return value. So on success, okay, or requested permission granted, our mode is if okay, and the file exists, it returns 0, I think. Okay, is okay, the file, okay, it returns 0. So in success it returns 0, and in failure or any error it returns -1. So we can check here. We say return the return value. On success it returns 0, and on error or failure it returns -1. So why we need here like return value? For checking if we have the permission of the file or not. So if we come back again, our function called access, and it checks the access on the file, if the file exists or not, and you can write or read or execute the file or not. And it takes two parameters, and you can open like a variable to store the returned value from it. And our return value, it will be integer, so 0 or -1. So our parameters, or sorry, our variable to store the result from integer value, and it takes two parameters. The first one is the file which it will check the permission for it, and the mode, which mode you want to check. So we can just like organize our thought here. So what do we need? Okay, we need to use this function. We can say the first thing is the variable to store the result from the function, and second thing, pointer variable to store or to hold the path name or the name of the file to be checked. And the third thing is like a mode is integer. Okay, right? Yes. Where? Yes, mode is integer. Okay, integer variable to store or to hold, but I think no, we don't have to like initiate a variable for it, because we just will write it. So now we know why we use or why we need this function, and what is its requirement to use this function, which is two variable. The first thing to store the result, and the second one to just hold the name of the file. So we can just try to write the steps if we want to make a code for using this function, but it's like simple code, just a simple code for explanation. So the first thing is just to like include the library. We shouldn't like forget the library. And the second thing to start or declare the variable which will store our integer or our result, and then start variable to hold the path name of the file, and then we will call, okay, call the function and store or save the result inside the variable, and then we can check for error, and on error we will print a message, and if there is no error we will print another message. Okay, so we can come here, bcd root, make dir, example, okay, vi, okay, مش vi, cd, okay, vi access dot c. Okay, the first thing we can hash include stdio.h and hash include text switch library needs to instead. Yes, yes, yes. Thank you. Include. Okay. Okay. Then we will open our main function, and then we will open our store. The first thing it's like int for storing the enter variable, so we can say result, and the second thing is for path name, so which like char path name. Okay, and this path name will equal to like example dot text, for example, and then we, like here in our steps we said that we should call the function, so here result equal access, and this access requires the path name, so we can just take it copy. The first thing is the path name, and second thing our mode, so we can just say ROK for read only. Yes, it's ROK. And then we will check for result, so we can say if result check for error, I'm sorry, equal to -1, that means there is an error and it can't access the file, so we print can't access the file. Okay. And else, that's mean it can access the file, or if the file exists and it can access it, so printf I can access the file. Okay, and of course return 0, and it's just I think just like, yes. What yes, it's equal -1. Okay, no, gcc access -o access. Okay, and okay, he say that can't access the file because mainly we doesn't have the file here, so let's try to make the file, or we can say vi example dot text. Okay. We can say hello world and just close it. So now we created the file, so it should, when I compile, it say I have the access or I found the file. So okay, I can access the file, and maybe we can just not that print what inside the file. So we can say I can't access the file, and sorry, and the content is /s. Okay, and the result. Okay, it's not the result. I think it's the bus name. Okay. Yes, it's the bus name. Okay, I can access the file, and the content is okay. That's the name of the file. Okay. So it's like mainly it's just explaining this function. So is everything is okay or not? Anyone is here? Yes. Yes, I'm saying, like, did you get it, or like there's something not clear? Okay. So should we move on the next one? Okay. Yes. Your mic. Yes. You mean like how can we use it, or when we should use it? Okay. In simple shell, in the project itself. Okay. Um, I think I didn't use it for my code. Look, my code is not the perfect one, and not all checkers works for my code. But for the some of the checker workers, I didn't use it. Okay. So, but yeah, like of course it's like someone use it and it worked with him. But it's like basically it's just check for files, and if you have the access on files or not. But I don't know on simple shell. Honestly, I don't know. You are welcome. Okay. Maybe the second one we can just check for getline function. This is one we used on simple shell. Okay. So here our getline function, and okay. Okay. Mhm. Okay, the first thing getline function, it's just when the user write anything on the terminal, getline function like take this line, and they make us have the access on this line and edit on it, or just print it, or do anything with this line. So this getline function, you can just imagine it like a delivery. Take something from one place and give it to you. Okay, maybe you can take from a file, or from the terminal, or from anywhere, not just as a terminal. Okay. So it takes, or it needs this library, and it delimits string input. Like it's like just to take the input, line input from the user, and give it to you. Okay. And just like we said, any function we need to use, it has some condition or some requirements, like its parameters. And if we want to store the result returned from this function, we should have like a store to save the result. So our store here like size t, and the name of our store y size t, because our function return the number of character it read, or number of bytes it read. So because that it return like a size of the line it reads, so we have size t. So it's like now it's our variable like store, okay, is for saving the result from the function. And the second thing it takes, it's a char line pointer, and that's mean like when the function like take the line the line from the terminal or from the file, it how it work like it's read, okay, wait, what, I'm sorry, can you say again? Okay. Okay, 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 thank you. Okay, like if we have our like our input here, well, like let's just say it's a hello, okay, world. How our function getline work, it just come here for like this is our function, come here, it reads the first character, and it should has a ours, it's here store, and it like reserve or save this character here. So it comes and read from here, like here it's e, so and come and save it here or write it here, and come read the L from here and write it here, like come and read L, the other L and the O and word it and write it here. So it should has like a temporary store, like because when it reads from somewhere, it write in another place, so you should open a place for it to like write what it reads. Okay, so because of that we have to have here a liner pointer, which is like a store, and this store is a temporary for getline function. When it reads some letters from the files or from the terminal, it's like save it temporary here. Okay, so because of that we have our char liner pointer like store for the line, maybe we can say line input from the user or from a file. Okay, and the third one is size n, which mean like when it take any character, it start counting the bytes of the line it reads. So if it read like hello world 10 or 11 character, it's like counting it and saves its counts a number of bytes here. So here it's a variable to store a number, okay, of bytes which the function read. Okay, okay, and the file stream, it's like a stream. You can think about a stream like a bridge or a connector between you and the file and the program. Like the program, now if the program is terminal or file and you are the user and you want like to get the line from the program itself, so you should have a connector or bridge between you and program to like have the access on this file. So a stream, it's like a bridge between you and the program to access the file or the terminal or anything to get the line from it. So our stream here just like a bridge between you and the program to make getLine function able to go to the terminal or the file and get the line. Okay, So here it's like standard input 0, standard input or standard output or standard error 0 and 1 and 2 that we know. So it's like a bridge between the user and the program to access the file. Okay, between. So we can read here. Getline reads an entire line from stream, storing the addresses of the buffer containing the text into liner pointer. So it's liner pointer, can we say temporary store for the line which we read. The buffer is now terminated and included the new line character if one was found. Okay, at the first, like, yes, this is good notes. When you start, you like, now if we want to use this function, we should like start our variables like a char line pointer and the size n, not here. Once we just create or declare these variables, we should assign the char pointer to null and the size by 0. And why is that? Just because getline function, it should automatically open a store in memory or a place in memory for this buffer or for this variable. So when you write a null and 0, you are saying basically that I don't have any space in the memory for these two variables and you should open spaces for them. But if you don't, if you didn't write null and 0 for both of them, it will give you like segmentation fault because will be a memory leak. So basically I'm always like forgot this step, so alhamdulillah I remember it now. So when we just declare our variables, we should assign them to null and to 0 to avoid any segmentation fault or memory leaks, because here you are just saying to the program I don't have any space in memory and you should open a space for these variables. Okay, returned value. On success, it returns the number of character it reads. Okay, so okay, not slack. Here returned value. On success, it returns the number of character it reads, and on error or failure, it returns -1, I guess. Okay. Okay, and on both function return -1 on failure. Okay, so I guess we don't need anything here. So we can ask what, for summarize, what we need to use this function. So for using this function, at the first we need to open like a store to save the returned value from the function. So the first thing, have a variable to store the result from the function, and the type of this variable is size t, and we said that size t because it holds the number of character it read. And then we have to have like, okay, not here, okay, this char pointer, liner pointer. Here you can have just a pointer variable or pointer to pointer variable. Both of them are okay, but the main difference between both of them, that if you just want to get one line, you can say char pointer line input, just one asterisk, it's okay because you just want to get one line. But if you have multiple line and you want to get more than one line, you have to say char pointer liner pointer. Why? Because in this format, like char pointer liner pointer, you can say what are you doing. You open an array, and this array for char line pointer and the char line pointer and the char line pointer, okay. So in this format, you are making an array of pointer variables, and each one of this array will point to lines. So if you have 3 lines, every pointer variable will point to one line. So this will point for line 0, which maybe we can say it's line 1, and this will point for line 2, and this will point for line 3. But if you have just one line, you can say char asterisk line pointer, because you just have one line and this will point to this line, okay. This, okay. And the third thing is like you have seisson, and this is variable to store, okay, we can say variable to store the size of bytes of line read, or the line we read, okay. So we can say what is the steps we need to just use this function, including the library, of course, including the library. And second thing, to open your variables or functions, variables. Okay, the first thing is size. Okay, size t. You can say result. And the second thing is line pointer, char line pointer, and this for storing the line. And fourth one is the fourth one. No, it's just it's right. Okay. Okay, size t n. Okay, size tn, and this for storing the size of bytes. Okay. So we can say after that you declared your you declared your variables and assign this by null at the first, and assign this by 0 to just say for the function I don't have a space in memory, and you should create a space to avoid any segmentation fault or memory leaks. The second thing is to just call the function and then check for error, and we can say on error print something or print a message, and okay, if there is no errors, we can print the line. Okay, we can just go here, okay, vi getline dot c, and just hash include stdio.h, and I think its library is stdio2. Yes, okay, int main. Okay, the first thing is to just start size t result, and char. We will use here just char, just one pointer to line, because I just will write one line, so it's line, and I will assign it to null at the first, and size t n, or asterisk n, and I'll assign it to 0 at the first, and then we can say result equal get. Okay, at the first I will just print the prompt, like print, yes, print f, enter a line, okay, slash n, and then I will call the function, so result equal get line, and I give it the parameters, which is a line and an n, and standard input. Okay, and then we can check for error if our result equal -1, print if error, else you can print we can print just the line. Okay, okay, but okay, let's see. I think maybe there's an error. Okay, I know where is the error, I think. I think it should be here. Okay, okay, here's the line of the result. Okay, line. Check. Okay. Interline and error. Okay. Thank you. أنا ما لحقتش أحط حاجة. Okay. Sorry, it's debugging. Yeah. I am not sure what is the error here, but yes, I'm sure. Okay, wait, just 1 minute. I'm sure because I did it before, so just 1 minute. I'll check with what is the error here. Okay, yes. Okay. Okay. Here, both of them, and we print the line. I think it should work. Okay. اوكي ماذا كنت علقت ليه؟ Okay, this enter line we just hello world and it prints a line. Okay, just the problem was here I didn't just put the ampersand symbol before the line and the n, and because I removed here one asterisk, I should remove one asterisk before the n too. So just was the problem. But here if just we can summary, just we have a store or a variable to store the result, and we have a char pointer which is and like our temporary store for the line, and the size n for storing the size of the line. And here just because I'm not in a big project like print is like simple shell, I just prompt to enter a line from the user, and I take this line and checked for error, and I said just if any error, like print error. If there is no error, just print the line again. Okay. uh, so is it okay or not? No, okay, like really there is no confusion or something. Okay. Okay. Yes. No, it's the best practice to allocate to avoid any memory leaks. Like most of our errors is just for memory leaks. For we have to, yes, it's a better. Okay, yes, are welcome. So, okay. Um, what else we have? Okay, open and read and close. So we can. Where is open? Yes. Okay, our open function here, it's open a file. If you want, if you have a file and you want to open this file to access it, to read or write or do anything on this file, you have your function open to help you open this file, and it needs three libraries here. Okay, let's go to the syntax. Okay, the first, maybe we can just make it. Okay, the first thing here, it's int open, and it is our variable to store the result from the function, and it's type int because it will return like integer value 0 or 1 or 2. So it's just a variable to store the return result from the function. And the char, like const char path name, it's the name of the file it will open. So it just is the name of the file, and these flags like what do you want from this file. You want to open it for reading, or why you are opening this file, like for reading or writing or executing something, or just mainly for what. So our our open function system call opens the file specified by the path name, and if it doesn't exist, if you have the option or create, it will create it. So our flags now, the first thing is create. If the file doesn't exist, it will create it. Okay, and okay, by created, okay, created by the open. The returned value of open is the file descriptor. So the returned value here, but okay, it's a file descriptor. Neon success. Our file descriptor, it's like an ID for the file, and this ID like explain if the file open on like input or output or error, which mean if the return value is 0, you know, like if the return value is 0, like our file descriptor is 0, that's mean uh, you open the file by standard input, so you can read from the file. But if it's like here, you can read or standard input, so you can read from the file. But if it's one, it's standard output, so that's mean you can write on the file or edit on the file. But if it two, it will be error. You are printing error message from the file. Okay, so our here we said that it takes like two parameters, which is the path name and the flag. So we mainly should look at what is the flag we have to if we want to open our files. So like our flag is here. The first thing is read only, and it's just to open the file for reading only. And we have write only, like opening or open the file for writing only. And you have O and ORDWR, which read writing. So it's here you are open the file for reading and writing, both of them. I think these are the most like famous one. Oh yes, append. Okay, here it's append. Here if you have a file, and like for example this file have a statement of hello world, and you open this file by write only, and for example you write hello C, what is happening that you are removing hello world, and instead of it like you wrote hello C. This is in write only mode. But if you open the file with append, so like the file have a hello world, and you like wrote hello C, so it will be like that hello C. And this is the difference between write only and append. Write only overwrite what is written or remove what is written from the file and write from the beginning. But append, it's just write from the next line or from the new line, doesn't remove anything. Okay. If you want to write and don't like remove what was written. Okay. And create, we said that if you use create with open, that mean like you are if the file doesn't exist, you just create it. Okay. uh, mm, I think these are the most common and the using ones. So if we just come back here, and so here for using this function we have we okay what yes, yes. Okay. Okay. um, okay, here we can say what do I need if I want to use this function. So as a first we need a variable from from integer type to store the result from the function. And we said that the result will be fd, or like integer value, which indicate fd 0 or 1 or 2. 0 that mean you are reading from the file, 1 you are writing on the file, and 2 for error. And the second thing, it's the char pointer, like pointer variable to store or to hold the name of the file. Okay, of the file. The third thing is the flags, and no, you will not just open any flag, only variable for this flag. Okay, so these are the main two requirements for the function. Okay, and then we just will go through the open and read and the close, and then we will take like an example on all of them together. Okay, so I think that's all we need from from open. But we have to check on returned value, it's the on error -1, not okay. Okay, return value, it's -1 if there is an error. Okay, so here we can say it's -1 on error. So we can go to read function here. Okay, here read, and it's a function to read from the file descriptor. So let's come here. The library to include is unset. Okay, here as the first thing, it will return the number of character it reads. So we have here size t integer. This is our variable which we use like a start or declare to store our result. And the first requirement of it's a fd. What is fd? It's the file descriptor. Okay, how I get this file descriptor? If we just remember that we said open function return a file descriptor as integer value. So our variable here, which will store the the result from open function, we will use it here with read function as the first parameter for it. Okay, so the first parameter, it is the returned value of open function. So we can say it's returned value from open function. Okay, this is the first parameter of the function, and the second thing is the buffer, and this buffer to store the character it reads. So when it reads, it will store the character somewhere, and the buffer, it is the place where it will store the character of it. Okay, and size t, it's like the number of character it already read. So it's a variable to store the number of character it already read from the file. Okay, we can come here. Okay, attempt to read up to count bytes from the file descriptor into the buffer starting at buffer. Okay. Okay. On success, it's returns the number of bytes it's read, and 0 indicate end of the file. And if the file position is advanced by this number, okay, this is okay. And in error, it's -1. So return it value. We can say on success, it's return number of bytes it read, and on error it return -1. So here, for using this function, okay, the first thing is just a variable to store, okay, here a variable to store the returned value from the function, and it will be size t because the returned value is number of bytes or number of bytes, yes. So the first thing, a variable to store the returned value. Okay, return it value, and it's a type from size t. Okay, the second thing is the first parameter is fd, which is the returned value from open function. So return it. The third thing is buffer, so it's like a char or pointer variable to store the line it reads. And the fourth thing is size count. Okay, size count, or it's like a variable to store the number of character. It's already read. Okay, so this is what we need for this function. And the mainly close function, it just takes the fd from open, so we can say close. The only thing it needs fd, which is the, okay, we can say the param fd, and this fd is the result from open function, so it doesn't need anything, it just is the result from open function. Okay, so let's try to make steps, and these steps to follow to like use open, read, close together. So the first thing, I need to open the file, and for opening the file I need the first variable to hold the integer value or the result from the function, so let's say int fd. And the second thing, we need to like have a char the path name. Okay, maybe it's the path, and this path holds the name of the file, so let's say example.txt. And the third thing, which is a flag, but we will not like open any variable for it. So the second thing, now we should call the function and store the result in fd, which is a variable, and then check for error, of course, check for errors. For then, like, we now will use read function. So when we use read function, we said that it needs the first thing. Okay, here read in using or read from the file, and this step takes the first thing, it's seisson, which is the variable. Okay, here okay, we can say result or number of character read, it's okay, anything. And this is like store for the returned for the result. Okay, for the result from the function. And the second thing we need in read, it's fd, so we don't have to create anything for here. And here it's a pointer variable for buffer, so here we have to like char pointer variable for buffer, and this buffer for storing the line or the character which it will read, and the size tn to hold the number of character to be read. And I think that's all for read. Yes, that's all. Okay, then after reading we should check for error, and then like we can say print anything, like if you want to print what you take or you read, so we can say print read character, and then we shouldn't like forget to close the file at the end. And I think that's all. So maybe we can come here, vi read.c, libraries. Okay, we looked at this library, this for open, and for read it's unlisted, it's not here. Okay, okay, for close we didn't come to close. Yes, it's unlisted too. Okay, and the hash stdio.h int mean. Okay, we have here here to start our variables, which is the first int fd, so int fd, then char path, and this path will equal example dot text. I think I have file by this name, semicolon, okay, and then flags, okay. We have to, okay, size t result, just to make everything. This is holding the result from read variable, and size t count to hold the number of characters which reread, and the char buffer, okay, and what else? Char buffer size t, okay, that's all. Okay, and then we'll call like our open function, so fd equal open, and we'll give it the path, and then the flag, if we just say we can open with read only, okay, read only, and if fd equal -1, that means there is an error, so print f error, else, so there is no errors, and it opens the file, so we have to like read from the file. So here, okay, if we follow the steps, we checked for the error, so we have to read from the file. So this is the result, equal read, and the first thing it takes is the parameter from open, it's a fd, and the second thing it takes, I think it's a buffer, okay, it's the buffer which will store what it read from, like inside this buffer, and the count, which is will store the number of character it will read, okay, and then we can like print if I like can read successfully /n. Okay, I think at the first we have to check for error, like if result equal to -1, okay, here I can't read, or I can't read, yes, I can't read, but else, so if the like the read function doesn't have any error, we can say print if I can fully, okay, okay, maybe we can print the content too, so we can say and the content is okay. This is inside the else of open, okay, so we have to close it and then close and fd, okay, I think that's all for here. So at the first we call open function and store the result here, and then check for error. So we said if there is an error, print error, else, so there is no error, call the read function and store the result inside this variable, and if it's error, like print I can't read, but if there is no error, print I can read successfully, and the content is, and print the content of it, and close fd. So I hope it works. gct, and I think we called it read -o read, read, okay, it's I can't read, okay, example.text, I'm not sure what okay, it's example.text too, right? I think it's the same, not here is the problem. Okay. Let's debug. Okay, char close FLD and buffer. Okay, wait. Okay. Okay, I think the problem is encoding the function itself, because it returned error. So it returned -1, so there is an error in the function itself. Okay, and I think it's I think we should just put this line as this %. Shouldn't. Okay, we should. Okay, and this. Okay. Okay. We can just open ChatGPT and let's see what is the problem here. Okay. Okay. It says that the problem in count variable should assign by value before using it. So I think it's the same problem. Okay. Okay, not here. Count assigning the buffer. Okay. It's a memory leak and memory problem. Okay, we should assign the count like by 100 and the buffer malloc. Okay, so not here. It's like after our error, should as a first our count equal 100 and our buffer equal malloc count. Here, like, just we have to open a space in memory for like having our buffer in this space. Like it's just we use open space for buffer, which is buffer. It's a variable which store our line or our what we read, and we should assign the value like yeah, like space, how much space you need in the memory for this buffer. So we assign the count here, which is number, like maximum number we can read. It's like 100 character, and we opened inside the memory space for 100 character. Okay, so I think this is what the error. It's a memory leak. Okay. Okay, because of malloc we need this function, this library. Okay. Okay, I can read this successfully and the content is hello world. So if we just like want to summarize this code again, we start fd and this is the variable which stores the returned value from open function, and our path, which is our file name, is size t for result, which holds the result from read function, and the result is the number of character it will read, and the count. So sorry, result will store the size of bytes. So like it is like the space, it should like if it read 100 character, it should like if this character from char point char type, so it will multiply 100 by 1, so it will be around 100 also. So it is the size of bytes, and the count, it's a number of character itself. So hello world, I think it's 10 or 11. So here in count will be 10 or 11, just number, which is for number of character. Okay, and the char buffer, it's like it will store hello world itself, and then we call open function by read only, and store the result in fd, which is the variable we declare for open function. And then we check for error. So if there is any error, we just print error. But else, so there is no error, we here assign like the maximum number of character we can read, it's 100. And then we open a space for buffer, which is our variable. We go to memory and we open the space, and this is space malloc count, which mean like we here using type char. So char, it is in space, it's by 1 byte only. So we here multiply 100 by 1 byte, so it's 102. So we open like 100 space in memory for buffer to store our character. And then we like call the read function and store the result from this function inside our variable. And then we check for error. So if there is no error, so just we said else print if the content of the file with statement I can read successfully. And then we close the file again. And for closing, we just pass the fd, which is the return value from open function again. So is it clear or not? uh, yes, of course, sorry. Yes. Yes. Yes, for free. Yes, yes, yes. You are welcome. Look, for simple shell, when I just was searching on Medium, I find like 3 articles. Two of them explain simple shell step by step, and one of them explain how to debug memory leak. I will send it on the group um, for you. That's why I want to say nothing else. Okay, you are welcome. So you want the file or? Of course, I will send it on the group. Okay. Do you want it now or just when finish the session? Okay. 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 So, um, so I think we have now fork and change dir. Maybe we can go through fork. Okay. Okay, we have change dir here at the first, so we can go through it. Okay, our function here it's called change dir, and mainly it's for if you inside the file and you want to change the directory while you are inside this file, you can do that by change dir function. And okay, the first thing, it takes this library unset and int change dir. The first parameter it takes just the path for this dir, and the int its return. Okay, let's look at the return value. On success it returns 0, on failure it returns -1. So because of that we have here our variable, and this variable we said like for storing the result, and our returned value here, which is the result will be okay, here on success it's 0, on error it's -1. So because of that we have our variable by integer value, and here we have the path name, which is the path to the directory you want to open. So it's this variable to hold the path for the dir you want to open. Okay. and I think it's too easy. So just what we need to use this function. The first thing is just a variable from integer type to hold the result, and second thing, it is the pointer variable to store the path for the dir. Okay, and okay, that's it. No end. So the steps, maybe we can just include the library, and then like declare the first thing, declare our variable to store the result, which is like, okay, result should be integer result, and the third thing, declare the path name, the path for the dir, so char path, and then we will like figure out which dir we want to go, and then call the function and check for error. And that's it, I think. Okay, so first, before doing that, we can just go back on this. Okay, maybe we can take this. Okay, cd alex. No, okay, print working directory. So this is our path, we just will go there. Okay, and cd go back, cd example, I think. Okay, that's it. Change dir dot c. Okay, we have to hash include stdio.h. So first include here we have Unstead. Okay, okay, the first thing we need, we set integer value, so okay, we just copy this and int result, and char path equal to and okay, nothing like that. So we can say result equal our function, which is called change dir, and we give it the path. Okay, and it's only the path, just to make sure it's only, yes, the path. Okay, and we'll check for error if result equal -1, which means there is an error. Print if I can't move, okay, wait, move to the dir, okay. Else, so if there is no any error, print if moved, okay, moved successfully. I think that's all. Okay, it's called moved successfully. So we now on the on this path or in this directory. So I think it's like very simple one. Wait, we can do something else. Okay, we can print we can print the content of the path. Okay, we can say moved successfully and okay. Yes, I think. Okay, we have here just I just print the name of the directory or the path of the directory to make sure that it's really moved there. So it's saying moved successfully and the path, its root, and Alex low level program. So it's working. And is it clear or mm, like anyone? Are you okay, guys? Okay. No, it's no, it will not move us to this directory. But like if you execute the file, maybe it will remove us. But I'm just here giving like a simple example for how what is the function do and how you can use it. But we didn't execute the file itself. You get me? Yes. Okay. Okay. We have here fork. Okay. This is one of important like functions here. It's fork. And the fork like create child process from the parent process. And okay, at the first just we can like discuss why we need fork. Sometimes we need two processes to just run together, or we want to do multiple function or multiple process together. So if we need to do that, we have to like split our process into two processes. So we have more than one process, and everyone or each one like do different things or like execute different code. So if we need to do that, we have fork. And for another reason, like excessive function which executes any command, we know that when we use this function, it overwrites all program, which mean like if you give this function command ls to use, or sorry, to execute, if you have in your in your code, like for example you have code here and you called your function excessive here to execute any command, and you have the rest of your code here just to print something or to do another or to call another function or to do another thing, your this excessive function will just like execute what before it, and it will do its work and it will remove all your code. So everything after calling excessive function will be removed, will not be executed. Because of that we need fork while we are using excessive function, because we just will fork this process into two. So one process will do this function and another process will make the rest of your code. So if we want to wait, the first, our fork process, if you have this is your process, your fork process will just like separate it, and will make both like two process. So the fork process is just for separate one process into two. One of them will called child and the second one will called parent. Okay. Okay, but why we need, or how excessive function work? Okay, excessive function here, if you have your piece of code here, okay, code, and your excessive function and another pieces of code, what it will do, it will like execute that, and it will execute the command it has, and it will remove all of other code and it will not execute it or not allow the program to execute it. So in this case we have a problem. We need all of our code to be executed. So what we'll do, like we have our fork which have this process, and it will like separate it into two. So the first one will call the child, the second one will call the parent. Here is the parent, here's the child, and the child will execute the excessive function, which is removing everything after it. So we just here will write this function and let it execute. It's a program, and in the parent we will have the rest of our code which we want to execute. So basically fork function, it's just to help us for like execute multiple processes together, or if there is any function like excessive function or execute function, when it overwrites the old code, we just use it to like prevent it from removing our code from the program. Okay, so this is just why we need a fork or what it mainly do. And if we come to the syntax, it just like it take nothing, void here, it take no parameters, and it return a bid. It's called like a process ID. And if we know that every process has its unique ID, it's like our national ID, like everyone have unique ID for him, and it's also every process it has its unique ID, like to be easy in the program to access on this process and to get information about this process. Okay, so here the fork return bid. We can say that the fork process or function have two returned value. The first thing is 0 and the second thing is positive number, but it's not like reserved one, it's just random positive number. And this is indication of the child and this is indication for parent, but that doesn't mean the child process has ID of 0 all the time. It's not ID of the child. It's just like, when you like point by your finger to someone and say that this is the child and this is the parent. So that does not mean the national ID of that someone you say it's a child is 0, and that doesn't mean the national ID of the parent is like the number you set. It's just like pointing to this process and say it's a child by 0. So the pointing itself by equals 0, and the pointing to the parent and they say any positive number for it. Okay, so here, sorry, here's the 0 and the positive number returned from the function. It is not the ID of the process child, because the child process not all the time the ID is 0. It's just like an integer value to indicate that is the child and integer value to indicate that is the parent. Okay, so fork here like create a new process by duplicating the calling process, and the new process referred as child process and the calling referred as parent process. Okay, and the returned value we can just go down. On success, a BID of child process is returned in the parent and 0 is returned in the child, and on failure it returned -1. Okay, so we can say BID, it's a hold returned value from the function, and if the returned value is 0, like we can say if BID of t equal to 0, that's mean we are on here, we are on the child process. But else that mean any another positive number, that mean we are on the parent process. Okay, but also we will say like if BID at first, sorry, BID t equal -1, that indication for error. And here we can say else if equal to 0, so we are on the child process, and else we are on the parent process. Okay, So we can say our steps for the first thing includes the library. Second thing, start PID variable, call fork. We can check for error at first, for sure, check for error. And the fifth thing, we can say, okay, if we are on the child process, print a message and the ID. And we can say if we are on the parent process, you can print a message, another message, and get the PID. Okay, so we can come here, vi fork.c. It takes which library? Okay, BID, and here you can say BID equal fork, and let's check for error. So BID equal to -1. That means there is an error, so print f error. Else if PID equal to 0, and that means we are on the child process. So print if I am the child and my BID, okay, we can say BID is get BID, okay. And this is another function to get the BID of the function. Else, so else here mean we are on the parent process. So I am the parent and my BID is get BID. Okay, I think everything is okay here. Fork, C dash O fork. Okay. Okay, I am the parent and my BID is 1525, and I am the child and my BID 1526. Like we noticed something here. Okay. At the first I checked for the child and then I checked for the parent, but basically what happens, the parent is printed at the first and then the child is printed. Why? Because the child starts from here and it's like started to scan this line, then scan these lines and these lines and come here. But the parent starts from here and it just print it's a statement and it terminated. Okay, so the parent doesn't start from the beginning or from start. It starts from just this line or from line of a checking of the parent. But the child starts from point of fork. Okay, so our child always starts from point of that fork, because of that you find always the parent execute his program and it terminates the program and doesn't terminate before the child execute his program and terminate too. So in this in this situation, there are two like status for the process. One of them called orphan, and another of them called zombie. Orphan status, like when like what happened now, the father is execute his program and it terminated the program and doesn't wait for the child. And the zombie, when the child itself execute its program and end the program and doesn't wait for the father because the father is like late now. So this is two situations we should handle them. And for handling the orphan, which is a father execute and terminates the program before the child, we always use the wait statement or wait statement call with the father or the parent to like wait the child, like both of them end together and terminate the program together. Okay. So and for the process ID, here the father, it's okay 1525 and the child is 1526. Like the child is uh, the process of the child is like after the father, because like fork separate one process into two. So the one it is like main process, now it's a main process like divided into two. So the father is well, like 152 5 or 25, and the like the child which is come from the father, it will be like after it. Okay, so zero and the positive number, it's not indication for the ID of the father and child. It's not just like identification or something by it, or a mark. When I find this mark, so when I find the zero, I say this is the child, and when I find a positive number, I say it's the parent process, not the child. Is it clear? Mm, okay. Indication, just the indication for, yes, indication for a child, just an indication that is the child process. Okay. So I guess I finished fork and open, read, close, change dir and getline and access, and this is all for today. Um, would you like to continue for something else, or just that's okay for now?